Hey, what's up? Nathan here from PH Studios. Welcome back to another tutorial. This one is from the XNA Space Shooter series. We're going to do an extension on the way the bullets work. And this was actually a request from a member on how to do a sort of multi-shot ability for the ship. And what he wanted to do is he wanted to create a system to where the bullets will be 2 bullets or more, if you want to, will be right next to each other on a certain angle. Now, this angle can be the rotation of the ship. Let's say you have your ship and you allow the ship to rotate instead of simply looking up like I have it on the completed sample. Or if you have your own little mouse pointer that tells you to fire to this mouse pointer and you're good to go. So the way this works is it may sound pretty easy to do, but it actually requires a lot of vector math and things like that. So what I did is I generated the complete sample here, and I'm going to demonstrate that for you, and then I'm going to talk about the math involved, and then we're going to go into the coding. Okay, so this is the completed sample. As you see, I'm rotating here and here. Now if I press M, that's to switch to enable multi-shot. I'm going to go ahead and kill this enemy here. Now I'm going to fire and I'm going to explain what's going on. Okay, so I fired, and what we're going to do here is I'm going to enable sort of an overlay for this video so you can see what vectors are where. Since you can see my mouse pointer on the screen and I can't really demonstrate it with this pause here. So what I'm going to do is I'm going to create a video overlay on this sort of screen, so I'm going to explain what's going on. Okay, so what we have here is we have a certain vector that holds the position of our sprite. Now this vector, depends on another vector's values, which is called the origin. Now I have a origin tutorial on the basic training series where I talked about the vectors. I also talk about the complications that an origin value does. So if you're not familiar on that, please watch that tutorial because I'm not going to talk about that in depth on this tutorial. Just basically what the origin is set up might kind of interfere with the way our vector is set up. And I'll kind of show that in the video here. Okay, so what we need to do is we need to get the center of this texture, and we need to get to it and make 100% sure that it is the center. Now the way we do that is we need to make sure that we reference the top left of the texture first. Okay, so now if the origin is set to the center point, we need to subtract that from the vector itself. So depending on whatever the origin is set to, it could be set to 0, but to make 100% sure, we need to subtract it from position. So position minus origin will give us the top left point of this texture. Okay, now that that is complete, we need to add the actual center, which is the texture.width divided by 2, comma, texture.height divided by 2. So we're getting to the center of our texture, and that will be the center position vector. Okay, now in this shot, you will see 2 bullets next to each other, side by side, shooting at a certain angle. Shooting wherever the player is looking at. Now, in order to do that, we need to generate another vector, and this vector is going to just simply have the angle of where we're going to shoot. Okay, the way the algorithm is set up is we pass it an offset value. We pass it how far to push the bullets. So not only does that vector we need to generate hold the angle it needs to shoot at, it needs to have the length of the offset value. So we need to push it by that amount. So when we get that sort of vector, we need to add the center position with that vector. And that gives us the current offset, which is the origin. You see, I pause the game right when I fired the bullet. So it might be 1 or 2 frames ahead, but you can see the bullets are pushed ahead of the player by this amount. That push is done by that vector I just described. Okay, so now that push will be the center vector. If you see the 2 bullets side by side right in front of the player, imagine a third bullet in the middle. That third bullet would be the vector we just demonstrated. So what we need to do now is we need to push the left bullet appropriately and the right bullet appropriately. And the way we do that is we need to get a perpendicular vector from the left and perpendicular vector from the right. And the way we do that is we simply add 90 degrees to one vector and subtract 90 degrees from another vector. That's the entire definition of a perpendicular line or vector, is that its angle is plus 90 degrees or minus 90 degrees. So we generate 2 perpendicular vectors, and then we simply add that, and then we have our 2 bullet positions. Okay, so that might be a little bit complicated, but hopefully the video overlay will fix that. Alright, so I'm actually going to quit this. Now, you want to go ahead and download. If you have your own project, you can do your changes that way. But for this tutorial, I'm going to extend on the completed code here. So if you go to the forums, and you go to PH Studio's content, and XNA, and a sticky will be completed games Space Shooter video series, a sticky topic or a pin topic, and you'll see the XNA 4.0 project down here. Go ahead and download that and open it, and we'll be good to go. Or you can just open your own project and go from there. Okay, now this is the completed one, so I'm gonna move this off to the side so I can use that as a sort of a copy and pasting so I don't mistype anything. Okay, so to get from the completed code here, this is the completed sample of the entire Space Shooter series. To get from that to the multi-shot takes about 13 steps. But that's not the only thing that we're going to be changing. We're also going to add the ability to extend on this. You can have sort of different special abilities that you can use. So I'm also allowing you to do that as well. Okay, so before we go into the coding, let me explain the way the bullet system is set up currently. If we look in the player class, we look in the update region, update and draw region, and look in the handle input method, we can see that if we can fire, we need to add a new bullet to play screen. So now this is the way the bullet system is set up. Every bullet inside the bullet system is checked for collision. If we look inside the play screen, we can see that the collision detection inside the update methods just checks to see if one gameplay object intersects with another gameplay object, we have a valid collision. Now, the gameplay object is incremented by the static add method, which we called before. So it adds a new gameplay object. So the way I was originally going to do this is I was going to create a multi-shot class. So if we have a multi-shot ability available, we just simply do play screen.add new multi-shot. But after thinking about that, imagine the multi-shot, we generate our own logic here. The multi-shot has one bullet to the far left of the game window, one bullet to the far right of the game window. Now that's going to be one huge hitbox we need to deal with. So the way I'm going to do this is to, instead of revamping the entire collision detection and bullet system, is just to be simple, we're going to create a generator method instead of a sort of a new sort of class for this. So the bullet system needs to have its own generator method, and that will add two separate, completely separate bullets, but it will do the math to set the bullets at the right positions. Okay, now you can make your own class and call this specialweapons.cs, and just have a bunch of public static generators that way. Or you can just add it to the bullet class like I'm doing here. Now they have to be public static because we will be calling it in the player.cs class. Now you can have the enemies do this as well. I'm just, for the sake of this tutorial, I'm just having the player have the ability to fire a multi-shot. So it has to be a public static to access it outside of the bullet class. It needs to be void, it's not going to return anything, and we need to call it by generate multi-shot. Okay, so now what we're going to pass this is a ship source, whatever fired the bullet, we need to pass it, a view port view, so we can set up the bounds, the float angle, and the float bullet offset. And my last recording, this is my third time recording this, because the first time I was an idiot and I spent 40 minutes just doing the tutorial and it was finished, so I kind of stopped the tutorial and I always watch the tutorial after I'm done with it. There was no audio. I forgot to tell Camtasia to record my microphone. So it was just 40 minutes of a quiet tutorial with me just talking to myself. So now the second time my microphone was ultra sensitive, so any sort of moving on my desk, it would count. So hopefully this third recording is going to be the best one. Now if you hear me kind of banging on the desk, or it's kind of, you hear some sort of things here and there, I apologize for that. I'm trying to make the appropriate setup to do this. Okay, so we have a generate multi-shot method that has a bunch of arguments and parameters. So now we need to create the algorithm, and instead of me typing the algorithm from scratch, I'm just going to copy and paste it from here. So this is the completed algorithm, and this is complaining because we need to do that in step 30. But let me explain the algorithm. At the very beginning of the video, I mentioned a few vectors that we need to create in order to do the math. One of the vectors was the very first vector we need to do is we need to get the center. We need to get to the actual center. And I mentioned that we need to subtract the origin from the position, and then we need to add the actual center of the texture. So this is what we're doing in this line here, is we're getting to the actual center point of the texture. Okay, so now we need to do the V offset. That first initial push I mentioned ago is that pushing those two single bullets ahead of the ship. And that is done by V offset. V offset gets the current angle we pass it. Now this can be the ship rotation, or it can be the mouse pointer angle, whatever you want it to be. We pass it to this method so we can have a sort of abstract multi-shot generator. So what this does is it simply just generates a single vector that is by that angle with a length of B offset. And then we simply do the initial push, which is the bullet center. We need to add the center vector with the vector offset vector. So we simply add these two vectors to get bullet center. So that's the first initial push. Now we need to push one bullet one direction and another bullet one direction. And again, the definition of a perpendicular vector or line is the angle is, you just add 90 degrees to angle and subtract 90 degrees from angle. So we get two perpendicular vectors. We push one bullet by one vector and another bullet by another vector. So that's what we're doing here. Okay, so bullet 1 offset is the first vector we need to generate to get the perpendicular vector. So we have the angle here. We need to add 90 degrees to get the perpendicular angle. Now we need to generate the vector by using these cosine and sine, and this generates a unit vector, and then we multiply it by b offset for that second push. Then, of course, we simply set the bullet 1 offset to adding these two vectors. So bullet center plus bullet 1 offset is equal to bullet 1 offset. Now we simply do the same thing for bullet 2 offset, except for we're going to subtract 90 degrees instead of add. So those are the two individual pushes for each bullet. Those are the two individual pushes for each bullet. Okay, so this is step 2, the algorithm. And the algorithm is complete, and we need to go on to step 3, which is to get rid of this little line here that it needs to change. So we need to generate a new constructor in bullet. Now this constructor accepts a third parameter, and that's the position. Public bullet. It's going to be the same thing, ship, same thing as you see above, ship source, and viewport view, but we need a third one for vector 2 position. Now basically we need to do the exact same logic we do here, but we need to do one more line, which is position, this dot position is equal to position. So we just need to set the position that we got from the algorithm. Now how do we make sure we do the exact same logic? Well, we can simply copy and paste this if we want to, or since we want to do cleaner code, we can be sure to call this by adding a colon here and calling it this, and passing it, we can just call the other constructor by doing it this way. Source, comma, view. So basically, we're calling this constructor initially, but this constructor calls this constructor. So it does this logic, and then it does this logic here. Okay, so that is step 3. Step 4 is we need to modify the initialize method right here. We need to modify this to allow rotation by the player. Now I did this because that testing that you saw, this completed sample you saw, is the ship rotates. I did not want to create a mouse pointer and do it from that way. So the ship rotates, I need to allow that bullet to detect that ship rotation. So inside the initialize method, we simply just need to, we have this, the velocity vector. So we have this, the -9 times 60, we need to cut that and paste that in the float speed. So since -9 times 60 is the right speed we want it to be, we need to put this in a speed value so we can use the mathematic way behind this. So we comment this line out. We're done with that vector. Let's just add speed here, just so we can uncomment that if we need to. And now we have a new vector we need to do, is we fire from the ship's rotation. So velocity is equal to speed, this speed value right here, times a new vector, and we use the ship's rotation for the actual vector math here. So this generates a new vector at the angle of source.rotation with a length of speed. So that gives us our velocity vector. So whichever way our player is pointing, it will be incremented by that velocity. Okay, so that's step 4. Step 5 is to, now we're into the actual creating the abstract way to do this. and to allow us to extend it if we want to. Okay, so step 5 is we need to add above the fields, we're in player.cs now, above the fields region, step 5 allows us to create a public enumerated value of weapon. And this is going to hold the list of special weapons we can do. We can have a single shot and we can have a multi-shot. Now you can add more to this if you want to, but for the tutorial there's just going to only be 2 shots that we can do. Okay, so that calls us weapon. Now we need a way to store the current selected weapon in our player class. So we need to expand the fields region, and at the very top of that, above rectangle bounds, let's add weapon, capital W, space selected, weapon. And we need to initialize that, so equals weapon.single. The first initial shot we can do is just the single shot we saw before. So that's step 6. Step 7 is we need to modify the way we fire the bullets. So we have the update and draw. We have the handle input. Below the handle input method, let's add another method called public void fire weapon. Now, the way the fire weapon does is we need to switch the current selected weapon. So depending on if our weapon is single or our weapon is multi-shot, we need to do the appropriate action on that. So if you are familiar with switch statements, it's like a think about it as an if statement. If selected weapon is this case, so weapon.single. Okay, so if the selected weapon is single, we need to do the logic after this colon here. So if it's single, we have our handle input method above here. Our playscreen.add new bullet. This whole line, we can simply cut this. Control X or edit cut. And we cut that and paste that after our colon here. Now after that semicolon at the end of the playscreen.add line, after that semicolon, just add a break. Okay. So if selected weapon is single, we need to add a new bullet to play screen, and then we need to break out of the switch statement. Case weapon.multishot. Okay, if a selected weapon is multi-shot, we need to call bullet.generate multi-shot. Now here is where it can be clever if you want to. The source is going to be this, the player fired it. The viewport is going to be the play screen.view. Now the angle can be whatever you want. You can use the mouse angle you want, or we can just do shift this.rotation, or just rotation. And the offset value, you can just type in 10 or 15 here, and we're good to go. Closing parentheses, semicolon, space break, semicolon. Okay, so that's what we're doing with the fire weapon here, is we need to generate multi-shot if it's a multi-shot, and if it's single, we just need to add a new bullet. Okay, so now we're not quite done with the fire weapon method. You see these 2 lines here in the handle input method? Cut these 2 lines here, paste them below the switch statement. So we can fire, we need to fire weapon, and this will do the entire logic we do here. So we should have if input.fire, if can fire, this should be blank. The if can fire, it should be blank. So what we need to do is we need to call fire weapon. Okay, so fire weapon will call this method here. And this method will do the appropriate logic. If we can fire, of course we fire the weapon, then we set can fire as false and time until fire to that amount. Okay, so that is step number 7. Now step 8 is we need to remove logic and if can fire, and we already did that, so we need to move to step 9, and that's good to go too. So in step 10, we need to call fire weapon, and I'm just going off the checklist to make sure I did everything right. Okay, so we did 7, 8, 9, 10, 11 in a short amount of time. Okay, so now we need to do step 11, which is to modify the input system, and we need to add a new property to switch to a new weapon. So expand the properties region, and at the very bottom, below public boolean fire, we need to add a new public boolean switch weapon. And this is going to get and return is new pressed key, and whatever button you want it to map it to, I'm going to map it to M for multi-shot. Of course, if you have more than one shot you're going to add, you might have like a bracket or something like that. So just replace keys.m with whatever you want to map it to, and we're good to go. So now step 12 is we're going to handle the new input in player. So go to player.cs and we're going to handle input. So below if input.moveRight, velocity is equal to vector2 speed velocity.y. Below these two lines, let's create a new if input dot switch weapon, closing parentheses, opening closing curly brackets, because we need to do some additional logic here. So if we want to switch weapon, we need to switch the selected weapon to the opposite value. So if selected weapon is equal to weapon.single, we need to switch it to selected weapon is equal to weapon.multishot. Else, selected weapon is equal to weapon.single. Okay, so if selected weapon is a single shot, we set selected weapon is equal to multi-shot. If the selected weapon is already multi-shot, we need to switch it to the single shot. Okay, so step 13 is a pretty complicated step. I'm going to take the logic from my completed sample and show you the result. So it boils down to the collision method. The collision method is the problem I encountered during the testing here. If we had the generate multi-shot, if it was like 2, for example, the bullets would generate and go away right away, because the 2 bullets will be so close together that they will be colliding and it will be destroyed. So what I did for the collision method is if the bullets are from the same source, which means we generate a multi-shot, those 2 bullets are from the player, they're from the same source, it ignores the collision. This was actually a premium member, sort of a premium only tutorial that I'll just include in this one, because there's no other way to get around it. Okay, so what we're going to do here is we need to set boolean the same source is false. We're going to assume that the same source is false. We're going to do our testing, and if our testing is passing, we're going to set same source is equal to true. So until our testing proves otherwise, our same source will be false, which means bullet A will be fired from one source and target will have a different source. Now, of course, a bullet can collide with a ship, so that's why we pass a gameplay object. So we need to convert target to the bullet. Now, another one from the basic training series, or it was from the advanced techniques series, I believe. I did a tutorial, a 10-minute, 15-minute tutorial on this as keyword. So if you want to get more information on that, you can watch that tutorial. I'll briefly explain what it does. Basically, think about it as an advanced casting. You used casting before. I think we did it here. Yeah, we cast this math.cosine into a float. So this returns a double. We're just casting it into a float. So that basically what this as keyword does is it converts target to a bullet. But the as also generates, if target is not a bullet, it's a ship. There's no way a ship can be a bullet. It will reset to B is equal to null. So that's why we test it here. So of course, if the target is a ship, this will become null, and we do not need to do this logic here. Okay. So, basically, if we have two bullets, bullet B and this, bullet B and our current bullet object, we need to gather two sources. And what we're using here is a type object, type of source 1 and source 2. And the way we do this is we call any object in C# allows this. We call that object .getType. That will return the type of the object. Now, that type of the object is in the type, it has to be a type. And that might be difficult to understand, but it has to be that. Now, that type object allows us to call .fullName. And the reason I did full name is because this will get SpaceShooter tutorial.ship or SpaceShooter tutorial.enemy or SpaceShooter tutorial.player. So we're just getting that entire full name and comparing the equals. If that full name is equal to another one, of course we're using the same source, so we set that to true. Okay, now if bullet A is not the same source as bullet B, we need to kill both the bullets. If they're from the same source, we ignore the collision. So that's step 13. Let's run this, compile it, and run. Hopefully I didn't mistype anything, and let's see what's going on. So we play game, we fire the bullets, except for the sort of a what's missing that way. Oh, yeah. Back in the Initialize method, we have float speed -9 times 60. Delete the negative sign, so 9 times 60. So that's what the issue was. Forgot that to write that in my notes. Okay, so now we fire the weapon, and it's that one. We press M, or the keyword you designated for the switching weapon, and now we have two bullets generated here. Now all this work, and what you see here is probably not that impressive. So what I'm going to do is I'm going to modify the player.cs class, and in the Initialize method, I'm going to set its rotation to, instead of -90 to 45. Okay, so now we can fire. First, look at our original bullet system. It's firing from the left turret. Or the left wing. It's not the left turret, the turret's in the middle. So the way it's firing is in the left wing. Now, let's switch the weapon. Now it's firing from the center point. So that's a lot more impressive if we allow any angle to sort of benefit from this. And these two weapons are, these two bullets are separate. Each bullet is separate, so let me demonstrate that. I'll fire one at the enemy. Oh, they're both done. I'm try it again. Yeah, okay. Apparently I can't demonstrate this when I want to. Yeah, you see the top bullet went through the enemy, and it just kept on going. So there we go. No. You get the idea, though. They're two separate bullets. One bullet can die, and the other one can keep on going. So that's it for this tutorial. I hope my microphone wasn't that sensitive. I didn't mean to bang on the desk, but sometimes I do that occasionally. For some reason, I don't know what's wrong with my setup. For some reason, it was picking up a lot more than it usually does, so I need to do some modifications that way. But I hope you enjoyed the tutorial anyway, and I hope you learned some things, and stay tuned for the next tutorial, which would be an After Effects tutorial. So I hope to see you next time. and I finally got through it. I'm talking and the audio is going up and down, so it's picking up my microphone. So the third time's a charm.